So hi everyone, this is Yutong from IoTeX. Today I would like share you two topics around. One is the first one going to be the recommended infrastructure setup. This we already shared this infrastructure guideline on the GitHub. So you can see there is the following link. Basically, this part is just is pretty similar. So you can find basically pretty much everything I gonna talk about in the following couple minutes over there. So first of all, this is just a guideline. Is how we set it up. Our cluster, like in our testing environment, in our currently in our testnet, and also in our current mainnet rehearsal. So this is not the only right way to set up the IoTeX nodes, but this is how we set up. We'll share why we think this what we think this it is good about. So what we are using right now, we're using we have two Kubernetes cluster. This is for the mainnet rehearsal. So we use two Kubernetes cluster, one in GCE, it located in US East. Another we set it up in AWS. This is in Singapore. So what we have is we like, because like we're running on GCE and AWS. So by using Kubernetes, load balancer setup will give us the GCE and AWS cloud load balancer in front of our services. And we also use probably it's better to go to the next slide. Yeah. So yeah, like since we are using the Kubernetes in AWS and GCE, basically is I think it's in GCE is called EKS, and in GKE, and in AWS it's called EKS. So when you set up, like if you have using Kubernetes before, and like maybe you are using Kubernetes right now, if you are using this service in AWS or GCE, when you set up your Kubernetes service, and if you select the type load balancer, you actually create a GCE or AWS load balance, which give you some benefits we'll talk about later. But let me explain the setup first. So there will be a load balancer in front of your cluster, and inside of cluster will actually in front of the IoTeX node we have Envoy proxy. So the reason we having this proxy, there are like two or three major reasons. One is you guys may already know for our API we're using gRPC. So in order to support gRPC on pure web application, which is like single page web application without a Node.js server or without any other server in the backend, we need to use like technology which come out like pretty recently called gRPC Web. So gRPC Web require a reverse proxy to change gRPC request to somehow like a HTTP 1 request, because a browser probably will never support HTTP 2. So that's to support like gRPC Web on pure browser application. We use Envoy proxy to do that transfer. And you can and another reason we use Envoy proxy is for relimiting and circle break. You can see the Envoy is coming from Lyft. Also, like they have another service called read limit. It's actually called just read limit. It's also coming from Lyft. So with the read limit, gonna use another Redis just for data storage. So you can set up. Let me go here first. So yeah, so in Envoy, you can set up read limiting settings for HTTP and HTTP2 request, and also you can set up a circuit breaker a policy for all your network traffic, including TCP, HTTP, and HTTP2. So with that, like that gave us a application level of protection for the IoTeX node. So the configuration we're using for, like, there are two HTTP endpoints we exposed. One is for the API, which is the gRPC API. Another is a static port to report house and promiscuous status. So for these two ports, we have like this relimiting setup by IP. The setup we use is 20 requests per second. And for the our like P2P network with which we use lib2p P2P is under TCP. So there's no concept of relimiting over there. But in order to protect the node, we use Envoy circuit break. That gave us like like that gave us we can set a threshold limit on how many connection we want, how many pending requests, how many retry, this kind of thing over the network traffics. So let's go back to this. Yeah. So the reason why we want to have a commercial load balancer in front of us is to protect a lot of lower level DDoS attack. So like TCP, sync flood, a lot of other level 3 or level 4 DDoS attack, like this kind of like Google or AWS, their load balancer already handle that. I think some of them are also handle some relimiting for you. So like I think this is really good. Like you don't need to do much of things for yourself, and they like these kind of things are very they require like network expert to do that. So since they already do that for you, like we should just take advantage of them. Yeah, as I said, what we set up is inside of like the cluster is like, since the load balancer already handle a lot of lower level DDoS attack protection for us. On our hand, the Envoy and rate limited just for application level rate limit application level protection. Yeah, and the reason why we use Kubernetes here is in our test environment we deploy a lot of different nodes. We deploy many nodes in the cluster. It's very easy to deploy. It's very easy to manage different applications in Kubernetes, and it's also very easy to upgrade different services. Also, Kubernetes have like really good cluster level house monitoring. We can set up like how we want to monitor our nodes, what behavior we want. And also like you'll have like a failure detection. You'll automatically start the nodes if it's crash. You'll stop routing traffic to the cluster if to the node if it detects it's now healthy. And the third is have like really strong operation toolchain, which we're gonna talk about later. So we use a lot of tools inside of Kubernetes to monitor, to operate the IoTeX node. And yeah, it's Kubernetes like is the same command, same thing, same setup. Like you use the same set of YAML file. If you're running on local in Mini Kuber, if you're running on AWS, GCE, or another cloud provider, it's just the same. You just set up the nodes, and like everything else is as long as you're using the same Kubernetes version, is the same kind of file, same kind of command you're using. So it's pretty universal. We just need to write all this the YAML file once, and we can use this basically everywhere. So that's why we like Kubernetes. Like it may feel a little bit heavy sometimes, but like if you prefer another cluster management tools, that's fine. But like we just feel like we're pretty comfortable with it. Yeah, so I talk about this. So for the rate limiting, we use 20 per second, and for the circuit break, the max connection we think is 50. Because lib2p basically will connect 20 peers, so 50 maximum connection should be pretty good. Yeah. So in some of cases, you may want to examine some of the requests from rate limit. Like so, please generate that request inside of your like cluster. So you route the traffic directly to the node in like to bypass the envoy. So you don't want to explore any public API backdoors to examine rate limit. But like that require, if you want to do that, you can do that, but it's pretty complicated, and it like also give you backdoor to the attackers. So yeah, if you want to examine some requests from rate limit, just do it like inside of data center, not go through envoy. Yeah, I talked about a little bit about the Kubernetes house pop little bit before. So we do have like if by default like the status port IoTeX node uses 8080 is both for house check and for the Prometheus we're gonna talk about later. For the house check, you can like basically we have this liveness and writeness port already exposed, so you can use that in your Kubernetes config. And yeah, like liveness basically means that the node is up, and readiness means like node is ready to serve traffic. So if the readiness is return okay, the Kubernetes will route traffic to this node. So if it's not okay, you will stop routing the traffic. If liveness is down, like the Kubernetes will try to restart the node, which is like it's pretty good. Like once you have this set up, a lot of things gonna be automatic. Yeah, I'll talk about the monitor on call and the operation here on our side. So there are a couple tools we're using. We think they are pretty handy. A lot of like the core part is Prometheus. This is the thing we use for collecting, sending out the matrix from the node, collecting the matrix, and all the matrix. Once we have the matrix, we generate dashboard. We use that matrix to create alerts. For our on-call rotation, we use PagerDuty, and for automatic deployment in Kubernetes, we use this Qevan. And we also use a very light tool called KuberSelect to tell us whether Kubernetes resources like a port or deployment or another anything is up or down. So I'll talk about them one by one. So yeah, like for Prometheus, there are three more major components. One is a dashboard, or like Larry already showed you the Qevan dashboard, and another is a Prometheus alert manager, which you can manage all the alert from the matrix you generate. And in Kubernetes, we use a tool from CoreOS called Prometheus Operator, which is a Kubernetes like operator tool to help you generate configuration and alert in Kubernetes style, which in that case, you don't need to deal with all the Prometheus configurations. So yeah, many of you already know the RTOS node expose the Prometheus endpoint by default at 8080 port if you don't change the status port and the /matrix path. So you can actually find that there. There are the node matrix already export over there. So yeah, Grafana is the dashboard. Like once you gather the matrix from Prometheus, Grafana is the dashboard. You can see the matrix, and for us, we do expose. We have a public Grafana dashboard. There are two. I think there are two dashboard we have over there. One Larry already showed you is this one, the one we created for the Mainnet Rehearsal. So you have like general overview on whether the chain is held, how the every delegate is doing, what's the current chain height. This is a pretty much new one. We have another old one. Like they have like more detailed data, but some of them are a little bit outdated. We'll update later. You have more detailed another data like how the network is going, is there any gRPC requests, and also the block processing time, DB usage, something like that. So so it's a pretty like this Grafana is like really nice tool to virtualize your matrix. So if you want to use your customer dashboard, you can do that. If you want to use our dashboard, just like we'll like update like, all lists and we'll maintain the dashboard, and like you're welcome to just will on our dashboard. And if you have any request to see something like on our dashboard, you're think gonna be good, you can also just ask us. We could add. So yeah, like once you have like one thing you can do with the matrix you get from Prometheus is building that like pretty dashboard. Another thing is you can generate alerts. So like in the Prometheus have like a thing called alert manager. Basically, is a thing which you can like create alerts from the matrix, and also like they have like a different channel you can send the alert to. So on our end, we have like 4 alerts. The first alert is very obvious. Like it's just like the chain height. If the height is now increasing for increasing very slowly for 10 minutes, we will get alert. And the second alert we use is boot node readiness. So for testnet, we have like 2 boot node. For currently mainnet rehearsal, we added to 4. So if there are no available boot node, we'll get alert as well if they are not ready. So the third alert is how the delegates is doing. Basically, I put that is like you guys if you guys are ready. So we ask your that's one of the reasons why we ask your IP and port. We get that for we use that for check if you are ready to also to collect your matrix to help like to see whether the whole network is healthy or not. So for this matrix, you can see is basically if less than 80% of you guys are not ready or will get pinned. And the last one is for our bots. So if there are less than 80% of our bots are ready, we'll get pinned as well. So yeah, I talk about Prometheus operator. Like if you use Kubernetes, like in like writing the Kubernetes YAML config, you will become like really handy. You don't need to deal with the Kubernetes Prometheus style configurations. To expose to live Prometheus, able to collect data from your service, you need to just define this service monitor, and you just select. You act like pretty much the same as Kubernetes services. You use a selector to select what things you want to apply on the service I want to apply, and what port, what's the interval of the collection, and that will become like the Prometheus operator will just translate Kubernetes services service monitor into a Prometheus configurations. And you can change that actually in real time, so you don't need to restart your Prometheus or like any your ports. So and same for the alerts. Once you create these Prometheus rules, and you can just you automatically create an alert for you. So it's also you can change them in runtime. You don't need to restart anything. So it's pretty good. Yeah. So once we have the alert set up, we have this thing what we're gonna do, or how we're gonna get alert, how we're gonna know there is something wrong. In that for doing that, we use this service called PagerDuty. So like PagerDuty allow you to integrate with Prometheus very easy. You just need to give them like set up a token in your Prometheus. You will just send the alert to PagerDuty, and PagerDuty allow you to like set up your team members and like the way you want to notify. They have the app. They will call you. They will send message. They will email you. So they will find any way to wake you up in the night if when your service goes down. So for us right now, we have like a on-call rotation over our engineer team. We have like 24/7 on-call rotation covered through PagerDuty. So if there are anything wrong, like basically we will get alert from the 4 alerts rule we set up, like I will already show you. So once that happens, we'll get page, and we'll our on-call will trying to figure out what is going on. Is there anything we can do on our end, or we need your help to fix something together. Yeah, so Kale is a tool we also use in basically everywhere in our deployment cycle. So it's a tool it will automatically detect your new build on Docker Hub or any other where if you set up. So here you can see we can set up a kill policy. Say like if we're gonna pull from Docker Hub every 3 seconds, and we'll need one approval from Slack. So by using this, if we push a new build to Docker Hub, you'll automatically pick up and ask approval for that build on Slack. So if someone say like so here on the you can see the example on the right side. So we'll just say approve for that new build, and your kill will automatically upgrade the node in our cluster to that build, without we actually doing any like fancy operation inside of the cluster. You don't need to kill it. You'll do automatically. You'll do the rolling upgrade. Kubernetes support rolling upgrade, but like this will just allow you to giving a command. If there is a new valid image on the Docker Hub, we push, and like you'll ping you on Slack, and you just need to enter chat in Slack, you automatically upgrade, which is great. So yeah, this Kuber Slack is like really just a very, I would say, widget. It's very small. It's very easy to set up. It just once you set up, it just tell you whether the resources you have in Kubernetes is healthy or not. You just send like this kind of warning message in your Slack room. So we use that like just to notice if anything went wrong in our cluster. So but not like major like disaster. So this is more like I know there's something now like restarting, but like the chain is still functional because we don't get paid from PagerDuty. But maybe we can take a look if we have time. Yeah, that's pretty much the tool we use for our operation. So what we will do on our end is like, as I said, like we have 24/7 on-call coverage. We actively monitor the chain health through the Grafana dashboard we have, through the alert we create, and you will eventually go to PagerDuty if something goes wrong. We will pin unhealthy node. You guys may already see already doing that in the Discord. We'll pin the owners. We'll tell you whether you notice there is something we detect on our end that the node goes wrong. If that happens, we want to work with your on-call together to digest the problem and fix it. So what we would like the delegates, basically you guys to do to make sure we have like healthy network, to have a healthy blockchain, is to first we would like you to respond fast for the incidents if they are happening. Like if we detect something wrong, if we get page, if we get up like in the middle of night or like in your middle of night, we want like someone can able to reply on Discord or reply to the instance fast. And also, like we want you at least have some basic auto restart policy for your node. If you want like peaceful night, if you don't want we bother you, like something you can do is just a very simple thing is just restart the question. If the node is crashing, just restart it. for Kubernetes, it automatically does for you. If you run in Docker, I think there are another command you can add. I think Zhijie gonna add that into the latest runbook. So that will like just help you to restart the node. Like if it's crashing from any runtime error. We suggest you to have some certain degree of monitoring by yourself for your node. So like we already exposed Prometheus matrix for you. You can use that to create your own operation pipeline. Similar, not maybe not like as complex as us, but like maybe like similar or smaller, like simpler for your convention. And if you are not the only one who operates your node, you may want a runbook for you or your on-call. Just like if there's something goes wrong, you can just follow the runbook. You don't need to like just do how to restart. You know how to switch to backup, how to like deal with different situations. So like that will be make like you and your on-call's life much easier.
Thank you, Yutong. Do you have anyone have any questions on any of these monitoring tools?
Yeah, so I see there are a couple questions on the Zoom. So the first question is, you will notify us is our node down or unhealthy, or we need to monitor the dashboard by ourselves. As I said, like we do have monitoring the alerts, but our alerts is currently is 80% of the node is up, but we do watch the dashboard sometime. So if the node is down, if we notice, if like we'll ping you. If there are more than 20% of node is down, we'll get alert and we'll just actively working on it. So it will be nice if you monitor your node by yourself. We will try to ping you if there's one node down and we find it out. But like if there's only one node down and we're like if it's in our nighttime, we probably will not notify you.
Okay. Yutong, if you could pass the host over to Dong, and he can start on the next section for Roll-DPoS and ioctl tool commands.
Sure.
Okay, cool. Yeah. So this is the third workshop from us today. I'm going to talk about Roll-DPoS and ioctl tool commands. The reason we want to bring up the Roll-DPoS again and again is it is so core part of the blockchain. And recently, when we start using the mainnet rehearsal, we found many people are still are not very familiar with it. And there are a lot of questions regarding to why I'm elected, but I'm still not producing the block. So today, I'm going to give a brief overview about it. And also you are very welcome to read our yellow paper. And also we have earlier other tutorial about Roll-DPoS. So the Roll-DPoS in a nutshell. On the left side, can I see here? Okay, cool. Yeah, from this chart, you can see among all the delegates who self-staked, they are all considered as candidates. So from all the candidates pool, we have all the voters vote for them, and the top 36 are elected as delegates. And in each epoch, we also have a rule mechanism to make randomly selected 24 of the delegates as consensus delegates, and that goes through critical thought, and with some seed that generated also from the delegates and also from other signals, and we make sure the true randomness of the selection, and the delegates also do a DKG to distribute the case. That is essential for later for them to do the block producing. So in each block that is being produced, one of the delegates would do the proposing basically assemble all the transaction into one block, and all other delegates in the same round, which are like 23 delegates, they would validate and vote for the block. Once the block reaches the consensus, that the block will be committed and broadcast through the network here. And then we do it again and again. So every epoch, we will change the we will change the delegates that is doing the block producing. So the chart looks a little bit complicated, but I also read some takeaways that is easier for people to understand, and also which is more important for you to understand why which round you are in, you are out. So the first takeaway is 36 top voted delegates are the consensus delegates. They are in charge of the block producing function. And in each epoch, right now in the mainnet rehearsal, which is it is 1 hour, 24 out of the 36 consensus delegates will form a committee doing the block producing. And one delegate out of the 24 would propose the block, and other 23 validated. And so linking back to the question, if you are on the top 36, there's still 1/3 chance you are not producing block. And this is by nature of the Roll-DPoS. Yeah. Right now, people may also look at the logs from your Docker and see, oh, there is one very common ask question, why I'm not a delegate, and it shows you are not delegate, but that might mean you are not in this round, but you will get into the round, maybe next epoch, maybe another epoch, and there's a chance for you are not doing the block producing. There is a detailed paper about how Roll-DPoS is working on our website. Everybody would be recommended to check it out. So this is about the Roll-DPoS. Any questions so far? You can ask from the Zoom. See it. Okay, let me talk about my next topic. ioctl 2 command. So right now I'm going to directly do a demo, and if you haven't tried many functions from ioctl, please do so after my presentation. That is such a good command tool. It's such a good helper to all the delegates for you to look at your reward, claim your reward, and also check out even the blockchain status. And basically, it is a simplified version of a blockchain explorer and also a wallet. Okay, this is what I'm going to demo here, and let me bring up my command terminal. So first of all, I want to show how you can set up the ioctl. In our documentation website, if you click from the left side, command line interface, you will see how it works. There's a detailed documentation about how to use the tool. And we have a very nicely written script for you to install. So you just copy and paste this into your terminal and hit enter, and you are good to go. And here I'm not going to demo this part because I already installed it. If you have installed it. If you type this, you can see the helper command. Also, please note for all the commands you can see here. You can just type this like a command account. You can see the further sub commands and also the helper information here. It's very nice. You do not even have to remember all the commands here. You just type and try. And second part, you can very easily to see all the delegates by this command. Delegate node delegate. You can see the list of all the delegates here. And please note there's an alias. Alias means you don't have to remember all the keys, all the wallet, and you just set up the local alias, which is local. You do not expose this information to anyone. If you happen to know, for example, if you want to check always yourself, for example, this one is yours, and you can put IoTeX alias. This is my counter alias, and I'm going to set up another's. You can also type set, all the parameters. You can set demo and this wallet address to be demo. So it's already been set. If you go back to this node delegate, you can see the demo here. So you can always keep tracking, for example, like yourself and how many blocks you produced, and even in the future, the productivity when we add it in the next version. And the next one, check the reward. And for example, I have this account to demo how we can see the reward. If you type the ioctl and check out the node part, and there is a reward command, and just type in your wallet address, you will see how many IoTeX is in the reward pool for you. And you can also do this by putting your alias as well. Sorry, this one. Yeah, reward one. It produces the same result. And if you, so the reward will be the reward pool for you to collect. You can do the reward claim by doing ioctl action. Ioctl action, there is a claim action. And if you put the reward, do the claim, you can see how you initiate this action. And here, the first one is how many amount you want to claim. Okay, before this, I want to show how you can see the balance here. Balance reward one. Okay, right now I have 194 IoTeX, and if I do the action claim, if I claim 100, and the data, I can put any data here, like a claim, and then -L gas limit, we can put 20,000, and the gas price like 1, and then which address would be the signer. You can also put your alias as well here. And once you hit here, you will type in the password that when you do the wallet setup. And here I'm going to type this password. After you done this, you can see your public key here and also the signature. So, so here you are going to sign this transaction. If you put a yes, the transaction is being sent to the blockchain. And also you can check out the transaction here by typing, let's see, action hash, and you can see that is already success. It's so fast, and it's almost immediate. So right now, you should be able to get this balance in your account here. $294 sweet. After this, because this reward might also you want to send to someone, maybe another wallet, and you can do it here from by doing the file control action transfer. So it's very similar to what we do for the claim, which basically send another transaction to the blockchain. And right now, I'm going to show how you can create another wallet so that we can send to. So it's actually inside the account, inside the account command. You can do the create add, and here you put an alias. And I put a demo. So you put the password again. Oh, doesn't match. Okay, let's do it again. It happens all the time. Okay, the account demo is created. Right now, we can do the action transfer, and you can transfer to the demo account with 100 IoTeX and data reward or something, and the gas limit, let's still put to 20,000, and the price 1/operator. Operator is the account that you're going to send from, who will sign the transaction. So here, that is the password for the sender. And you are going to sign again. After you sign, it's going out. And let's do the control account balance directly of this. Oh, sorry, we don't have to do this. Let's just do the demo account balance 100. So fast. All right. This is almost everything about the IO control, but I'm also going to show you in our newly created Explorer how that can be shown as well. So if you go to the IoTeX scan, you can see in the blocks section, you can see all the action I did in this height. You can see from this sender to this recipient, and this is the transaction hash that we just did here. And also, if you are interested to do the development by yourself, for example, like you can. So first, you can the Explorer is open source. You can fork it and do your own Explorer, and you can also contribute back to this Explorer. And also, we can do some maybe you can do also further development on top of the Explorer by using the GraphQL. So GraphQL is part of this API query technology initiated by Facebook. And here we also use the same standard here. And if you go to the IoTeX scan.io API gateway, you can actually see this playground. And so here, the first command I can show here is if you query the chain's data by doing this query, chain meta and return would be the height and number of actions, TPS, and epochs, which basically what we show in the front page here. If you query, you already get it. It's very easy to use and very friendly of the return data that you can directly put it into some JSON compatible languages. So here I can show the query of a particular wallet address, and what we get is what we will get will be the count meta, which is address, balance, nonce, and also the pending nonce. You can directly get it the balance. Please note the balance itself is measured in raw, which is the smallest unit that we spot here. You simply transfer it to IoTeX. Cool. This is what This is what I'm demoing here. And if you have any questions, please ask here on Discord.
Thanks, Tom. Okay, I'm going to move on to the next section. So this next section is going to be on rewards.
Yeah.
You know, throughout the last month or so, we've gotten several questions about rewards. So this session is just to break down each component of the rewards. And I'm going to send everyone the latest version of the profit calculator in Discord right now. So I just put it in the mainnet rehearsal. This is kind of the spreadsheet that we use. Please note that it's assumptions based. There's instructions in the spreadsheet, and it kind of reflects the current voting scenario, which is around 640 million tokens that are staked, which amounts to 750 million total votes, which includes all of the bonus votes that people have set. So just to jump right in, so we want to just review block rewards, foundation bonus, and the epic bonus reward. All three of which are different in nature, but kind of combined to create the balanced reward structure that we've set. So the first one is block rewards. The amount of block rewards is fixed, and it's also based on a threshold. It's 16 IoTeX per mined block, and that's paid immediately after the block is mined. The eligibility threshold is, throughout the 2019, we're going to have different phases of the mainnet. So in phase 1, there's going to be 12 elected delegates running consensus along with 24 robo-delegates. We're going to add elected delegates one by one, kind of how we're bootstrapping the mainnet currently in the rehearsal. So every week or so, we'll add one delegate to the pool until there are 24, and that's when mainnet phase 2 kicks off. And the difference between these mainnet phases is just the amount of rewards, specifically the epic bonus reward, which we will review later. The maximum rewards from this pool, from these block rewards that a delegate can get, is 1.4 million IoTeX per year, assuming they don't miss any blocks. And the math behind this is every epic, there's 8,640 blocks, and 24 delegates are randomly selected to mine every epic. So that means that 360 blocks per epic per randomly selected mining delegate. That multiplied by 16 IoTeX per block equals around 5760 IoTeX per epic per mining delegate. And based on the fact that the chances that a delegate would get selected to receive this 5760 IoTeX per epic is 2/3. That means on average, every top 12 delegate for now will get 3,840 IoTeX per epic on average. And that's kind of built into the profit calculator, which you can review for yourself. So, to estimate this part of your rewards in any kind of models or things that you are building yourselves, we expect that, mainnet phase 2 or 3 will begin around Q3, Q4 respectively. Maybe not, directly at the beginning of Q3 or Q4, but, somewhere around there. It depends on how the consensus kind of progresses in the network. And, based on that, what we've built into the profit calculator is just kind of a expectation of, how often you'll be mining. And, again, these block rewards are only for delegates that are mining blocks. This next piece is the foundation bonus, which is also a fixed reward. It's based on a threshold of the top 36, and it's provided by the IoTeX Foundation. 2 delegates only for the first year, kind of to help with the setup costs and all those good things. So it is a fixed reward. The maximum, the way we came up with this, and this is something we wanted to mention. It was kind of misrepresented in earlier materials, but the intention of this reward was always to give 8 extra IoTeX per block to the delegates that were mining. And originally we only had this set to whoever was mining, but we decided to open this up to all of the top 36 delegates. So to make this clear, the 8 extra IoTeX per block would equate to around 700,000 IoTeX per year. It's basically taking the maximum delegate block rewards, which are based on 16 IoTeX per block, and adding 50% to that. So this is where the max rewards per delegate comes from, 700,800 IoTeX per year, and that's given to all of the top 36 delegates. So this is a threshold-based reward and only offered to the top 36. So to estimate the rewards from this piece, you basically multiply the number of days you will expect to be top 36 by 1920 IoTeX. The last piece of the reward is the epic bonus reward, which is variable, it's not fixed, and it's also threshold and it's votes-based. So the threshold itself does not really apply right now. In the future, if there are more than 100 delegates, and people ask when the time would be for the point in time where there may be 100 delegates is, in the future we're going to have certain requirements that, to propose changes in the network or to vote on certain things, you would have to be a delegate. So that's kind of the incentive in the future. But for now, I think we're at around 50, so this threshold does not apply. For the variable reward, this is much easier to calculate. It's just taking you get X% of the epic bonus for X% of the votes, and that's paid at the end of every epic. So say, for example, a delegate has 2% of the votes, they would get 2% of the epic bonus, which currently is 300,000 IoTeX per epic. So the basic way to calculate the epic bonus reward would be taking the average of the epic bonus across mainnet phases 1, 2, and 3, which is roughly 375,000 average, and basically taking your percent of votes that you expect to maintain throughout the year, and that gives you a very accurate estimate of what this piece of rewards will contribute. So putting it all together, just wanted to give you an example of a delegate with 2% of all the votes. Right now, since there's 750 million votes, that's around 15 million, and currently ranked number 18 on the list. So the amount of block rewards they would get is, they wouldn't mind for maybe at least the first 6 weeks because, they're ranked number 18 and they need to be gradually replaced with robo delegates. So, just assuming that you miss 1/8 of all the blocks in the first year, you would get 1.25 million for block rewards. Maintaining top 36 would get you 700,800 IoTeX, assuming they're top 36 for the whole year. And finally, the epic bonus would amount to around 2.75 million IoTeX, assuming that you maintain 2% of the votes for the whole year. So, we encourage everyone to think about their scenarios, especially when you're paying out rewards. Now that you have a better understanding of, it's important to realize that, only the epic bonus is guaranteed for now. So being upfront with your voters, saying you're going to offer 100% of your block rewards when, you aren't mining is, not a very transparent way to do it, which is why we want people to use the epic bonus as the primary kind of payout. So, we mentioned in the earlier instructions that everyone should try to update their rewards. Ideally, what we would want is everyone to just basically tell people what they plan to do with each of these different segments of rewards, not just giving one. I see a lot of people just saying 80% payout to voters, you should be a little bit more specific. If that truly does mean 80% of all the different buckets that you would receive, that's great. But if not, then you should try to be more specific with that. And we added a functionality to the website where you can kind of apply a new template. We also want you to add your payout frequency. I think I've seen a lot of interesting automatic payment tools. So I think those functionalities are coming both from Delegates and the IoTeX team. So take that into account, and I think it's good for voters to understand your plans for paying out those rewards. And finally, this is just the snapshot of the profit calculator, the results. On top of this, there's a top section of assumptions that you can toggle. But right now, this is kind of the lay of the land, right? Number one has around 48 million votes, and this represents about 750 million total votes. So you can see that the rewards are kind of distributed throughout the top 36, and just wanted to make it clear here on the ROI why this is the case. So it's kind of the balance of the fixed rewards, which are the block rewards and the foundation bonus, versus the variable rewards, which are from the epic bonus reward. So at the top here, the majority of the rewards for delegate number one will be coming from the variable reward, while the majority of the rewards coming for number 36 on the bottom will be coming from those fixed rewards. So that's kind of how the design, we want to incentivize everyone to make a healthy return. So it's kind of a good balance of the fixed and the variable rewards. So we encourage everyone to review the profit calculator in more detail and let us know if you have any questions. I think community definitely appreciates all the different voter calculators that have been designed. So I think making them more specific, just to really hash out on this point, to give transparency to voters, is something that's going to be very helpful. And just for everyone's knowledge, our IoTeX brand ambassadors are going to be kind of maintaining rewards payment spreadsheet where they're going to vote for all of the delegates and basically see what kind of returns and what rewards are paid from those delegates, like when they're paid, if they're the correct amount is paid. And this is not to try to be the police, but I think from research into other networks and things like that, this is one of the kind of the issues that always keeps popping up that can be avoided pretty simply. So we're just trying to avoid those preemptively. So if you have any questions on reward payouts and things like that, you can discuss with us at a later time. So now we're going to move on to the next section, which is how to fast sync with Zhijie.
Hi, this is Zhijie from IoTeX. Yeah, this is going to be a very, very quick session. So in this session, we are talking about how to do the fast sync with the IoTeX blockchain. I guess most of people here has joined the mainnet rehearsal 2 days ago, and they have experienced how to keep syncing with the blockchain. So it's going to be time consuming, especially when the blockchain has been operated for a pretty long time. If you want to sync from the block one to catch up the tip height, it's going to be take a lot of time. So to overcome these issues, what we provide now is a solution of the archive. So I'm not sure if Yutong has mentioned before, in our blockchain infrastructure, we actually will do a daily backup from some nodes basically to do is to stop and archive the current blockchain snapshot and upload it to this Gcloud. So on the Gcloud, we will have our most latest snapshot being published once a day. So the link here is pointed to the data set that we put on the G-Cloud. So what you need to do if you want to do a faster sync with our blockchain, what your operation will take here is download the data from this URL and enter this table and copy the PodDB, ChainDB, TriDB into the IoTeX _home /data. Then when you start your blockchain node, you are not going to just sync from the block 1. Instead, you will sync from the most recently snapshot. But probably you're going to only have a gap of at most 1 day's blocks. So from there, if you want you do the sync, it's going to be much quicker. And in the latest release, we also fixed the block sync efficiency. It could have been, I think the RC7 could have been as fast as 300 blocks per minute. So I guess within about 20 minutes to 30 minutes, you should be able to get synced with the blockchain tip height. So this instruction is most important for the folks who haven't started with our blockchain yet. If you haven't started, when you want to start to join the blockchain network, please use this fast sync mode. Thank you.
Thank you, Zhijie. Yeah, and before we go on to our guest presentation, we want to remind you guys that RC7 has been released. It's a compatible change, so you guys can install it without pausing your machines. So everyone, please do take a look at RC7.
Yes, today we also planning to upgrade it to the release candidate 7, and this is going to be a compatible upgrade, which also means it's a soft fork. So all you guys need to do today is to restart your node with this new Docker image, and you don't need to clean up your local state this time because it's a compatible upgrade. And
Great.
this is going to fix a few problems, also including some new API features that allows you to look at more details about the delegates, like if you are among the top 36 delegate pool and what vote you have, such as things.
Great. Yeah, any questions, please feel free to ask in the Discord. So we're going to move on to a presentation by DRoute. So DRoute is one of our delegates. They're working on a networking layer 0 for blockchain networks. And they're actually creating a plugin that other delegates can use to test out their proprietary network. Yeah, perfect.
Yeah, thank you, Larry, for the opportunity to present as a guest presenter. And as Larry said, what we've been trying to do is to build a layer 0 network for cost effectively and efficiently transport the blocks and transactions of all blockchains. So I know that there has been a lot of creative work and protocol work that has been done at the consensus layer, at the the layer 1, if you will, to increase the degree of decentralization and scalability. What we are doing is trying to help those efforts by building a low latency, highly performant layer 0 global architecture, right? Global network that is fully decentralized, and it's low latency, highly performant, and completely autonomous. So that's the kind of the solution that we are bringing to the table. A little bit about the team. The company is premised on a decades-long networking problem that was solved by our founders at Cornell, by a professor and a faculty member and the PhD student at Cornell, who are the founders of the company. And our company, the team is a good blend of networking experts. I myself come from the networking industry. I worked in CDNs. The last company we sold was a CDN, and the CEO, Bob Rizika, comes from the networking industry. I worked in the wireless and wireline networking industry. And we've got a lot of, and we got a bunch of talent from the blockchain industry as well. As you can see, the Kademlia inventor, David Mazuris, the co-founder of DRoute, and the CIO of Bitfury, is on a technical advisory board. So what we've done in this company is put together a good blend of people with strong networking expertise, networking skills, and blockchain and crypto. So just a little bit about the blockchain scalability problem, which most of you are aware of, and I'm not going to spend a lot of time on it. Blockchain has a scalability problem, right? I mean, for the technology to be truly global and truly real, its TPS rates have to significantly go up. And a lot of the new blockchains, like IoTeX, for instance, a lot of the new blockchains that are in the market now in various levels of testnet and mainnet are trying to do exactly that by coming up with better consensus protocols, better layer 2 sidechain solutions, off-chain solutions, if you will. But the fundamental problem is the limitation or the bottleneck still remains the underlying physical network. So, there's a good analogy that I can use for this. Let's say that you build a Ferrari, or a Lamborghini that has the best consensus protocols, or that can, travel as fast as it can. But if it's going on roads that are filled with potholes, where there's a lot of congestion on the road, then it is limited by the performance of the road. It is limited by the condition of the underlying road. And that's the kind of similarity that we like to use here. If you're using a network that has a lot of packet losses, that has a network congestion, network latency, then it really does not matter how efficient your consensus protocol is, because it is fundamentally dampened by the network layer congestion and the physical congestion and the packet loss. So what we are trying to solve is that problem, right? We are trying to solve that network layer problem, because of which the Ferrari can now run or ride as fast as it can on a global autobahn. So that's the analogy that we would like to use here. So this is very coincidental. While we were working with it, I happened to meet a professor from USC who is working with whiteblock.io that does blockchain testing as a service. And they're just going to release this paper. They've actually released this paper as a preprint right now. They're going to be talking about it, publishing it in a conference in South Korea in May of this year. And what they did here is they tried to do empirical performance evaluation on the EOS blockchain. So what they've done is they saw around 180 to 200 TPS, and the whole paper is going to be available pretty soon. They have the 21 blockchain producers and clusters, and when there was zero latency, which is the which is not practical, but it's the theoretical maximum TPS that you can reach, they saw the TPS of the blockchain at around 180 to 200 TPS. Once they simulated a latency or increased the latency, because this is in a test lab, to 50 milliseconds, the TPS fell down to 50 transactions per second. And at 100 milliseconds, it fell down to 35 transactions per second, right? And when they induced a packet loss of 1%, the TPS completely collapsed. Now, this is not specific to the EOS blockchain. This kind of behavior will be seen on all blockchains, and it's not specific to the consensus protocol that this specific blockchain uses, EOS blockchain uses. This kind of a characteristic where as the network latency increases and packet loss increases, the TPS reduces significantly will be seen in any blockchain using any consensus protocol. So that's the fundamental problem and the challenge that we have that we are trying to solve. So I've talked a little bit about it. So the current network solutions is, why not internet? Internet, as I said, there's congestion, the performance is not predictable. There are no SLAs. You cannot get a service level agreements from the internet. So why not private circuits or private connectivity, right? Number one, it's not decentralized. You've got to get a private circuit from a specific service provider or a network operator. It's extremely expensive. It's actually designed for a point-to-point connection, right? It doesn't support a peer-to-peer broadcast primitive, which is a fundamental protocol in all blockchains, and because it's not because it's not software configurable, you cannot provision it in real time, right? You cannot provision a circuit between a certain specific set of block validators and then bring down the network later on, right? I mean, especially in consensus protocols where the block validators and producers are chosen at random, you want these networks brought up and down in a very flexible, rapid way. And in a private connectivity kind of approach, it's very difficult to do that, right? So our solution can scale up and down connections between block producers and validators based on demand, and it's a two-way global, truly decentralized autonomous network, right? So I kind of referred to this a little bit before, but fundamentally, we have built a global network, and we have come up with a virtual routing solution that has solved essentially a high-profile mathematical differential equation problem. So all networks are basically, all packet switch networks are basically feedback control systems, right? I mean, so in the case of TCP, if you have a packet loss, the TCP windows decrease, and so the whole TCP transfer protocol itself is a feedback control, but the time scale of that feedback control is extremely high, right? So what we've done is we have solved the characteristic equations, underlying the differential equations describing this packet switch network, and we are able to make these link provisioning and link partitioning decisions at every node in a decentralized way every 150 milliseconds. So we are running these algorithms in a decentralized way at every node in our global POP every 150 milliseconds. So we are able to react to packet losses, sudden increases in network latency extremely quickly. And that's the reason why we are able to guarantee network latency variation, guarantee extremely low packet loss, and guarantee low bounds for network latency, right? So this is our DRoute network that we've built, which is a global network. And we have gone to each operator in every country and build a blend of networks from using circuits and POPs from multiple operators. So that's why it's a decentralized network, and a single network operator cannot bring down the network, right? And these contracts require, almost 2 to 3 years for us to get all these contracts with the national service providers in all these different countries. and that's a big challenge if people dealing with contracts and regulations with the network service providers. It's extremely challenging to build such networks, but that's exactly what we've done. So we've built a global network which is decentralized, and we are running our virtual routing algorithm on each of these nodes in this global network. And that's the reason why the network is global, it's decentralized, low latency, and extremely high performant, right? And as a comparison with the internet latency variation, you can see that, we did some network testing, actual network testing, and actual network testing between multiple node pairs, as you can see, Sydney to Tokyo, San Jose to London, so on and so forth. And over the internet that's shown in red, the internet latency variation can go all the way to 150 to 175 milliseconds, right? So it's all over the place. With us, the latency variation is bounded to 5 milliseconds, again, precisely because we are able to reroute around failures, and we are able to dynamically adapt to momentary changes in the network condition and in the network, right? So what we are bringing to the market is essentially a DRoute Connect, and this is what Larry was talking. This is completely open source, and using DRoute Connect, you don't. Again, the DRoute Connect uses the public internet, but we have built a slew of network and transport optimizations to increase the performance, the throughput, the TPS, and decrease the block propagation time. So this is completely open source, and we are working with multiple blockchains right now to show them the performance increase, and working with miners and validators to get this plugin integrated into these nodes. And the other thing is, so this is how we go to the market. This is open source, and we have a switch in there where if you want to use the global DRoute network that I was talking about, then you just turn on the switch, and now you're going to get much better performance, even more than what the DRoute Connect could give you, right? So that's the model, and you can start out with DRoute Connect, and you can flip a switch to connect to the DRoute network to get a much higher degree of performance in TPS. So fundamentally, DRoute is a global, decentralized, low latency network infrastructure trying to help blockchains achieve the 3 legs of decentralization, security, and scalability. Right?
Great. Thank you so much, Ram. And I just wanted to mention to all the delegates that they should definitely watch out for that, and looking forward to hearing more about the plugin. Yeah, so that concludes our orientation call today. Thank you so much for everyone that's joined. We dropped a couple materials in the Mainnet Rehearsal chat group, so do review the calculator. Review the different monitoring tools and on-call tools that Yutong had asked or shared with us, and also the ioctl commands and fast sync. So any questions, you could feel free to ask us in the Discord channel. Just wanted to briefly review the next steps. So this is our Mainnet Rehearsal guide, as you guys are well aware. So some things that we mentioned last time is, please do send us over your primary technical contact information, and also go to the IoTeX voting website. We added a new section here where you can add your server endpoint, which is what is being shown, what is being used to ping your servers and show that your systems are online. And it's a beautiful site, seeing 28 nodes already mining on the rehearsal pipeline. So thanks so much for that. Next, session we're going to have is going to be on Tuesday, April 2nd. It's going to be at the same time, 7 a.m. Pacific Daylight Time. And what we're going to be doing here is repeating the bootstrapping process for the second time. So, this past Wednesday, when you guys had started your machines, you will keep those machines running until April 2nd, where we're going to start again from block 0. So going through the process of setting up the node and joining in consensus. Again, we're going to do this for a third time. I think this one is going to be more of the fire drill session, where we're going to walk through these different situations, emergency stop, different hot fixes, and rollback and recovery. So it's going to be a different flavor, but still also very important to attend. And I think sometime in between, these various events, we're going to have another call just to answer frequently asked questions and walk through maybe some more detailed walkthroughs of Kubernetes and any other technical topics. So during that session, we also invite other people to give their guest presentations. If you guys are working on anything interesting or want to share something with the delegate group, this is a great forum to do it, just similar to what DRoute and Ram had shared. So thank you again for that. And we are still tracking the progress of the mainnet rehearsal closely. So hopefully everything continues to go smoothly. Thank you guys so much for attending again today, and we will see you guys on Tuesday.